Another proposition for you. Well, this proposition says, let's take a look at this together. For any integer like a, this is a cool one. And any prime number like p, if p divides a, if p is a factor of a, then p is not a factor of a plus 1. Okay, very well. Let us try to prove this. Suppose not. And you can find an integer like a. There exists an integer like a and a prime number like p. Such that p divides a, p is a factor of a, and p divides a plus 1. Very good. So we are stating the negation of this statement. Remember the negation of this statement. So if you have for any x in D, P then Q, it's equivalent to not P or Q, then the negation of this statement is there exists x in D, P and not Q. So suppose not. Suppose the negation of this statement is true. Okay, can we get to a contradiction? Let's see. Very good. Take a look at this. Since P divides A, it means that A is PK, K is an integer. Very good. Since P divides A plus 1, so A plus 1 can be written as P times L. L is another integer. Very good. Okay. Take a look at this. A is equal to PK, A plus 1 is equal to PL. What happens here? If I just do the substitution, PK plus 1 is equal to PL, or 1 is equal to PL minus PK, or 1 is equal to P parentheses L minus K. What's happening here? This guy says P is a factor of 1. So P divides 1, but P is a prime number. P is a prime number. Prime number. Remember the definition, P is larger than 1 by definition. So we get to a contradiction. This is our contradiction. P dividing 1 or P is a factor of 1 is the contradiction. So we reach to a contradiction for the negation of the original statement. The negation is false So it means that your original statement is true. So since the negation is false, so the statement is true. And we're done with this proof. Let me write this true here.